Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from integration. And in this class, we are going to discuss this important problem where we are given a function f which is defined as f of x is equal to 1 plus 1 over x times the integral from 2 to x, and we have f of u du, and we have to find out the value of f of e, right? So here what we will do, we'll first solve this equation and to get the form of the function f of x. So once we get the function f of x, we can easily find out the value of f of e by substituting x is equal to e, right? So to solve this problem, we have to make use of the concept of derivative and an important theorem from definite integrals, right? So let us solve this easy problem by using the concept of derivatives and definite integrals. So let us first multiply throughout by x, right? So we have the equation f of x is equal to 1 plus 1 over x integral 2 to x f of u du. So let us multiply throughout by x. So we'll get here x times f of x, and here we'll get x, and then here we have this x and this x get cancelled, so we have the integral 2 to x f of u and du. So this is the first step in solving this equation. Now let us differentiate both sides with respect to x. So we have here d by dx of x f of x, and here we have d by dx of x, and here we have d by dx of the integral 2 to x and f of u du. Now here we can make use of the product rule, that is the derivative of the product of u and v, which are functions of x. We have u dv by dx, then we have v du by dx. So here the first function may be taken as u, that is x, and second is v, that is f of x. So we have x, the derivative of f of x is f prime of x, then we have f of x, and the derivative of x is 1, and here the derivative of x is 1, and here the derivative of this integral is simply f of x, because here we can make use of an important property from definite integrals, that is, if we have y is equal to the integral a to x, say f of u du, then the derivative of y with respect to x is given by simply f of x, right? So this property is being used over here. So we have here simply f of x. So now we have x f prime of x plus f of x, and this is equal to 1 plus f of x. Now f of x and f of x get cancelled, so we have simply x f prime of x is equal to 1, and f prime of x is equal to 1 over x. So now we have a simple differential equation here, that is d by dx of f is equal to 1 over x. So we can simply integrate both sides with respect to x. So we have integral df over dx, and here we can write dx, and here we have 1 over x dx plus c. C is the constant of integration, right? And f is f of x. So here we have simply f of x, that is f, and here the integral 1 over x dx is simply natural log of x, and c is the constant of integration. So now the function f of x is given by this expression, and we have to find out the constant of integration by using some condition, right? So here to get the condition, we'll here substitute x is equal to 2, right? So taking x is equal to 2 in the given equation, we can see that we have f of 2. Here we have x is equal to 2, then here we have 1, and here we have 2. Here we have 1 over 2, and then 2 2 2 because x is 2, and here we have f of u and du. Now the value of this integral is 0, being because here the limits of integration are same. So the lower limit and the upper limit both are same, so the value of this integral is 0. So we have simply f of 2 is equal to 1. Half times 0 is 0, so this is simply 1, right? So when x is equal to 2, f of 2 is equal to 1. So let us impose this condition on this equation. So here taking x is equal to 2, we have f of 2 is equal to natural log of 2 plus c, and f of 2 is 1. So here we have 1 natural log of 2 plus c. So c is equal to 1 minus natural log of 2. So taking this value of c in this equation, we can now write f of x is equal to natural log of x plus 1 minus natural log of 2. So our function f of x is now given by this expression, and we have to find the value of f of e. So let us take x is equal to e in this function. We have f of e is equal to natural log of e plus 1 minus natural log of 2, and natural log of e is 1. So we have 1 plus 1 minus natural log of 2, that is 2 minus natural log of 2, right? So the required value of f of e is given by 2 minus natural log of 2, and this value can also be expressed like this. We can write 2 as 2 times natural log of e minus natural log of 2, and this is natural log of e square using the properties of log, and here we have natural log of 2. So again, using the properties of log, we have natural log of e square over 2, right? So f of e can also be given by this expression. Hello viewers, in today's session we are going to discuss another important problem from functional equations, and in this session we are given this problem where we have a function f such that 2 times f of sine x minus f of cosine x is equal to x square, and we have to find the form of the function f, right? So here we are given a functional equation where trigonometric functions like sine x and cosine x are involved, and in order to solve this functional equation, we'll make use of some important trigonometric identities, and then the method of elimination, right? So let us start. So we are given this equation 2 times f of sine x minus f of cosine x is equal to x square. So let us call this equation as equation number 1. And here we can see that x belongs to the set of real numbers, right? Now see, from trigonometry, we know that sine pi by 2 minus x is equal to cosine x, and cosine of pi by 2 minus x is equal to sine x. So we'll make use of these two important results. So let us replace this x by pi by 2 minus x, right? So when we replace x by pi by 2 minus x in equation number 1, we'll get 2 f of sine pi by 2 minus x, and then here we have f of cosine pi by 2 minus x, and in the right hand side we have pi by 2 minus x square, right? So we have 2f, and here sine pi by 2 minus x is cosine x, so here we have simply cos of x, and here we have f of sine x, because cos pi by 2 minus x is sine x, and in the right hand side we have pi by 2 minus x square. So we can make use of the identity that is a minus b square is equal to a square minus 2ab plus b square. So here we have pi square over 4, then we have minus pi x plus x square. So let us call this equation as equation number 2. So now let us multiply equation 1 by 2, so that we can eliminate f of cosine x in these two equations, that is equation 1 and equation 2. So multiplying equation 1 by 2, here we have 2 times 2, 4 f of sine x, and then here we have minus 2 times f of cosine x, and here we have 2x square. So let us call this equation as equation number 3. So now we'll add these two equations so that we can eliminate f of cosine x. So here we have positive 2 times f of cos x, and here we have minus 2 f of cos x. So adding these two equations, these two terms get cancelled, and here we have 1f sine x, and here we have 4f of sine x. So adding these two equations, so we have minus f of sine x plus 4f sine x, and then here we have pi square over 4 minus pi x plus x square, and then we have this term, that is 2x square. So these two gives us 4 minus 1 is 3, so 3 times f of sine x, and here we have pi square over 4 minus pi x, and 2x square plus x square is 3x square, right? Now dividing both sides by 3, we have f of sine x is equal to pi square over 12, and here we have pi x over 3, and here 3 and 3 get cancelled, so we are left with simply x square. So this is our equation number 4. So now we have this equation, right? Now let us replace this sine x by theta, right? So we'll make this substitution. Sine x is equal to theta, so that x is equal to sine inverse theta, and the principal value branch of sine inverse function is given by this interval, that is minus pi by 2 to pi by 2, right? So replacing sine x by theta in equation number 4, we get f of theta is equal to pi square over 12 minus pi by 3, and for x we can write sine inverse theta, and here we have plus sine inverse theta square, right? So now we have an equation f of theta is equal to pi square over 12 minus pi by 3 sine inverse theta plus sine inverse theta square. So again replacing this theta by x, because using the concept of dummy variables, we can now write f of x is equal to pi square over 12 minus pi by 3, and here we have sine inverse x plus sine inverse x square, right? So this is the required form of the function f, that is f of x is given by this expression.